So now we will talk about calculations involving the mean and standard deviation, or the variance. So first we can talk about combined sets of data. Say it tells you large bag of sweets contains 72 sweets having total mass of 852.4 grams. Small bag of 24 has mass of 282.8 grams. So it's asking you to find mean mass of all sweets together. So what you would do is, there is a formula, but I mean, really I don't know why you'd have to use this. It would be the sum of x plus the sum of y divided by n of x plus the sum of n of y. And so from that we'd get 852 plus 4 plus 282.8 over 72 plus 24, which is equal to 135.2 over 96, which is equal to 11.825 grams. Now, if it had given you potentially the mean of the sweets beforehand, so if it had given you the mean and then asked you to figure out the combined mean, you would then have to multiply them by the n to get the sum of x and sum of y before you can actually calculate the combined mean. You cannot just average the two means. That will not give you the right answer. Now, it could also, now an example involving variance. 25 values of p have sum of p squared equals 6006 and sum of p equals 388. 25 values of q have sum of q squared equals 6114 and sum of q equals 387. So it asks you to calculate combined variance. So what we'd do is you'd do sum of p squared, 6006 plus q squared, and divide that by 50, and minus 388 plus 387 over 50 squared. And so that would lead to 2.15. So basically the main point here is when you have to find the combined mean or the combined variance, you pretty much use your formula, but you need to be mindful that you need to separate. You cannot just average the variances. They need to be p. You have to add up. You have to imagine that each p and each q are individual values of x, so you have to add all of them together, and then for this one you have to imagine each sweet is a value of x, and you have to add them all together and divide them by the new number of sweets to get your mean. it's really not that hard. You may be given a different combination. You might have been given the combined variance and then had to find like the sum of Q, but it's just a bit of algebra, and so you should be fine with that. An example of like some of the rearrangement you might have to do is find of employees in a company if sum of the employees squared sum of x equals and the standard deviation equals 18. So have a look at your formula. Standard deviation is the square root of sum of x squared over n minus over n squared. And by the way, the n is number of companies. We also don't know that. So we set 18 to equal 8,900 over n minus 220 over n squared, and we can square this. 8,900 over n minus, well, 220 squared over n squared. Sorry. And so if we multiply all sides by n squared, 4n squared equals 8,900n minus 4,400, and you can start to see we're getting a quadratic equation here. It may just be worthwhile to just instantly move to the quadratic formula, so n will equal 8,900 minus b minus the square root of 100 squared minus 4 times a times c, all divided by 2 times a. That gives us 20. So then we can go sum of x over n, 220 over 20 equals 11. So that's an example of the rearrangement you need to do. What the general strategy is, write out the general unrearranged formula, to substitute in what you know, then it will become obvious which is still the variable you need to find out, and then you can use your algebra to rearrange it and get that isolated.